Hi, hello everyone. It's Ibrahim Olawale here. Today we want to look at WAEC 2003 Mathematics Theory. And we have the question as follows. In the diagram, PQRS is a circle with center O and radius 7 centimeter. And we are told that SQ and PR intersect at K. And SKR is equal to 90 degrees, which we can see in the diagram clearly. If the length of arc SR is 4 times that of arc PQ, find the length of arc SR. Now, we are given this condition that if the length of arc SR, so we have the length of arc SR, the length of arc SR is 4 times that of arc is 4 times that of arc PQ. Now, one thing I want us to take note here is that when we are talking about length of arc, the arc is always subtended, always subtends an angle at the center of the circle. So we need to find the angle each of this arc is subtending at the center of the circle. And also, I want us to take note that the length of arc is proportional to the angle. The length of arc is always proportional to the angle subtended at the center. Subtended at the center at the center at the center of the circle. So what I'm trying to say here, permit me to use equal sign for that proportional. That is, the length of arc is proportional. Or let me cancel the word equal to so that we won't get confused. So I will use this symbol for proportionality, something like this. So the length of arc is always proportional to angle subtended at the center of the circle. So what I'm trying to say here is that the bigger the angle subtended at the center of the circle, the bigger the length of arc, and vice versa. That is, the smaller the angle subtended at the center of the circle, the smaller the length of arc. So here we are going to focus majorly on the angle each of arc SR and each of arc SR and PQ will subtend at the center of the circle. So in this diagram, I will make a little construction. So I need to connect a line from this center of the circle to touch this point R on the circumference of the circle, thereby forming a radius. Here. So we know that this radius is 7 centimeters. Let's take note of that. So, and I will also join a line from the center of the circle to touch point P on the circumference of the circle. That one also will be a radius, so which is 7 centimeters. So let us label the angle that this arc PQ subtend at the center of the circle to be theta. So let's label it to be theta. So if this angle is theta, what can we say from there? So by our knowledge of circle geometry, we know that angle subtended at the center is twice angle subtended at the circumference. So if you check this arc peak here, it subtends angle theta at the center of the circle and also subtend an angle at the circumference, which is angle x here. So by the theorem that says angle subtended at the center is twice angle at the circumference, I can say that theta, this theta that is the angle subtended at the center, is two times angle PSQ. By our knowledge of circle geometry, that is angle at center is twice angle at center is equal to two times angle at circumference. Let me shorten the word circumference like this. Okay, so therefore angle PSQ will be theta divided by 2. So I will have this angle here to be theta divided by 2. Next, let us check the angle that arc SR is subtending. First, we should take note that this angle, first we should take note from the condition we are given that if the length of arc SR is 4 times that of arc PQ, we have to find the length of arc SR. So, like I said, that length of arc is proportional to the angle subtended at the center of the circle. So if angle POQ is theta, by that statement that the length of arc SR is 4 times that of arc PQ, it means that the angle that will be subtended at the angle subtended by SOR will be 4 theta, since the length of arc is proportional to the angle subtended at the center. So I should have the angle that is subtended by this arc SR at the center to be 4 theta. Now let us check, is this SR subtending another angle on the circumference? Yes. If you are to trace it like this, it's subtending angle P at the circumference like this. So what will this angle P be? That's the next question we need to tackle. So in this case now, by virtue of the theorem that says angle at the center is twice angle at the circumference, so I can say that angle SOR is 2 times angle SPR by this theorem. Same reason we go for this. But we know that SOR is 4 theta. So which will be equal to 2 times angle SPR. So let me change this to angle. So that angle SPR will be equal to 4 theta divided by 2. And that will give me 2 theta. So in this case here, angle SPR is equal to 2 theta. Okay? Now, The next thing we want to do now, we need to find, actually, we are finding the value of what theta will be. That is our main objective. So in order to find what theta will be, let us consider the right angle triangle SPK. Because if this is 90 degree, here should be 90 degree. We should know that by virtue of angle on a straight line. So let's consider right angle triangle SPK. So if we consider, that is, consider this is the diagram here. Consider right angle. We should consider right angle PSK. We have that 2 theta plus theta over 2 will be equal to 90 degree. And where is this coming from? It's coming from complementary angle. Two angles are said to be complementary if they add up to 90 degree. If they add up to 90 degree. So this is complementary angle. Now, why do we say this is complementary angle? Since if you observe this right angle triangle here, we already have one of the angle to be 90 degree, and that means that the two other angles must add up to 90. So which confirms the property that two angles are said to be complementary if they add up to 90 degree. So when we simplify this by our knowledge of LCM, that is, we can clear the fraction by multiplying through by 2. So when you multiply through by 2, the LCM is 2. The LCM of 2 and 1 is 2. So from here, this is just basic fraction, which I know that we should be able to handle. So if I clear fraction by multiplying through by 2, I will have 4 theta plus theta to be equal to 90 degree. So from here, this will give me 5 theta equals to 90 degree. And when we simplify further, we are going to have theta to be, and when we divide this by 90, 90 divided by 5, that should give us 18. Okay, that should give us 18 degree. I'm correct about that. Theta should be 18 degrees. Oops, there's a mistake. Oh, sorry. We are clearing fraction by multiplying through by 2. So that means I need to multiply this 90 by 2. Sorry about that. I need to multiply the 90 by 2 so that this can be, I need to clean this. I'm sorry about that. So that this can be 180 degrees. 180 degrees. And when you divide that by 5, we are going to have theta to be 36 degrees. So this will give us 36 degrees. So the angle that is subtended at the center by PQ is 36 degrees. So definitely the angle that will be subtended by SOR will be equal to, we can say that angle SOR will be equal to 4 times 36 degrees. 4 times 36 degrees. And this will give us 144 degrees. So that means the angle subtended by arc SR at the center is 144 degrees because of the condition that says if the length of arc SR is 4 times that of arc PQ. So, and like I said, length of arc is proportional to the angle subtended at the center of the circle. So from here we can get the length of arc SR. So we know that length of arc is given by this formula. So let me just say length of arc SR now. So I'll just go straight up. The length of arc SR is given as theta over 360, theta over 360 times 2 pi r. So our theta now will be 144 degrees because it is arc SR that is subtended at 4 theta at the center now, divided by 360 times 2 pi r. That will be 2 times. We are asked to use pi to be 22/7, and our radius from the question is given as 7 centimeter. So that is 7 centimeters. So I'll multiply this by 7. So simplifying this, we are going to have the length of arc SR to be 17.6 centimeter. All right. So that settles it. That settles the question. All right. So feel free to subscribe to my channel for more videos on any questions on mathematics, be it WAEC, NECO, JAM. So see you next time. Thank you.